Hey James, I think you've got some very interesting, new developments around smart packaging and something that you'd like to demonstrate coming from Canada.
Yes.
Part of the Canadian Pavilion.
So at Jones Packaging, we're a folding carton manufacturer and standard packaging supplier, and we decided to add some functionalities to this package. So on this package, we have an invisible code that's printed on the outside. It uses the electrical impulses in my own body to activate my touch screen. So here we've built an app just to demonstrate this. And you can see that I've just activated the touch screen using this carton and the invisible code printed on there. The idea behind this, a lot of our customers are in the pharmaceutical space, so we're thinking of this as an anti-counterfeiting technology and brand authentication. What we have on this carton, on the back side, we have an invisible code that's printed underneath decorative inks. The code is using a carbon-based ink that is conducting what's in the electrical impulses in my body when I hold this section here. When I do that, it essentially extends my fingers onto how the touchscreen works, and it uses the Muiti-Touch technology in the screen to identify the unique code that's in there.
So where are you printing the conductive ink? Is that on the surface, embedded in the paper layers, or on the other side?
We've actually printed it on the surface, so we're unique in the sense that we've been able to print this through a sheet-fed offset printing press. However, we have an analox coater at one side of the press. We print the carbon conductive on that layer with the analox coater. Then we print whites over top on the same pass. We wait for a day for drying. The carbon likes to oxidatively dry. Put it back through the press and use all the decoratives to cover it up. And the idea behind this is that yes, the code is there, it can be identified using a mobile website or an app, a native application. You can actually verify and validate and authenticate. But the beauty of this is that considering you can't see it, it's very difficult to actually counterfeit. That's the idea behind it.
How easy or indeed difficult was it to get it to this point? And how did you overcome those problems?
Well, we overcame those problems primarily through working with partners, understanding the fact that decorative inks do not work in any way, shape, or form like a conductive ink. The drying systems we had to really be modified to try and cover that off, but working with partners was key. The first time we ran this, just from a metric perspective, we had a little test bar that we used to see what the resistance level was on this just a little trace. And the first time we ran it, we got 120 kilo ohms of resistance, which really was not good, especially considering the screen needs somewhere around 9. So the next time we ran it, with the help of our Sun Chemical, our partner in this area, we were able to get that run going from 120 kilo ohms right down to about 8 on the very second try, and it had a lot to do with how they blended that pigment.
Did you have to invest in new equipment to print this, or could you use equipment you already had access to?
Fortunately, in our case, we already had access to this equipment. We didn't have to invest. But moving forward with some of the other technologies that we're actually working on, we will need to invest quite a bit in terms of drying technology on our flexo presses.
Can you talk about some of those technologies you're working on?
Sure. So something we've decided, or what we're doing here, is this is the project that we're working on with the National Research Council, and effectively what we have here is what we call a compliance card. So each of these bubbles represents a location where you would put a prescription drug. And as I flip this over, and keep in mind this is a prototype, it says Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, so on and so forth. So days of the week and time of day. And when we open up and pierce through and push this drug through the card, what ends up happening is when it's connected to a device, in this case we have an interrogation device, we can actually cut into this, and I'll do that right now. So
watch the screen as James is actually doing that.
So this is just representing the same idea as pushing one of the pills through the blister. And let me just get that through. So I think I picked Tuesday bedtime, and I better turn it on first. So this is interrogating through this entire section, and just a second here. There. So we can see the Tuesday bedtime has now been hit. And I think I'm touching something.
You want perhaps hold it?
That's better. Yeah. So here I'll do it again. No,
so you're touching the
I'm touching the conductive section. There. All right. So I cut through. So now we should see Wednesday bedtime. Perfect. Yeah. So the idea behind this technology is to try and increase drug compliance, and by pushing through and detecting this, This would be connected to a consumer electronic device which has an embedded smartphone or an embedded cell phone inside. It would send text messages based on, uh-oh, mom forgot to take her pill. I would get a text message, now I could nag mom. That's the whole idea behind it. Now this technology here does require capital investment of drying, primarily drying on existing flexo presses today.
So Jones is a significant packaging company. You've got a product here which looks in the works, ready to go. What are your next steps in terms of taking this to market?
Well, the next steps, we've proven that we could do this repeatably and reliably. The next step is really about finding customers who are willing to take that plunge. And fortunately, we have several customers that are currently in process of looking at expanding content. They want to do more than just what's on the package and deliver more content to their patients or consumers. So we're working on a few programs right now to actually commercialize this into real products.